Hi everyone, welcome to BHARGAV SUBS. So in previous class we discussed regarding the potential due to a conducting surface, okay, or conducting sphere at a point P. Okay, we placed a charge. So due to that, what is the potential created and what is the charge induced in the conducting sphere? We discussed the two things, correct? So what is first one? Potential. And what is second one? Induced charge. Induced charge. And if the charge was induced, like if the charge was present outside, due to that charge there is a creation of surface charge density now on this conducting surface, because conductor contains free electrons. Conductors contains free electrons when a charge was present plus q. So due to this Satya, due to this positive charge, the negative charge was attracted to one side. It was contained like overall surface. So due to that plus q charge, some negative charges comes to the one side, so that there is a creation of surface charge density on the surface. So I have to find this surface charge density. Surface, this was denoted by sigma. So surface charge density. So what is surface charge density? Now I want to find the surface charge density. Let us find, see what the result will come. So you know, like I find already the potential. So let us take that potential, and with the help of the potential let us find the surface charge density. You know what is electric field? Okay, sorry, what is the formula for electric field? So electric field is equal to minus dV by dr. So differentiation of potential with respect to r is equal to electric field is equal to sigma by epsilon, correct? So sigma by epsilon. So if I want to find, this is the formula, if I want to find surface charge density, no, so sigma by epsilon is equal to minus dV by dr. So sigma is equal to minus epsilon naught dV by dr. So surface charge density is sigma is equal to minus epsilon naught dV by dr. You know the potential at point P, Vp, we already find that. What is the formula? Q by 4 pi epsilon naught into 1 by root over r square plus a square minus 2ar cos theta minus 1 by root over a small r by capital R whole square plus r square minus 2ar cos theta. So this was the value of potential. Here capital R is the radius of the conducting shell. Small r is the where the point is taking, where the point was considering. Tell me one thing, where the surface charge density will lie? On the surface, no? Okay. So on the surface means at what distance for a conducting cell? At a distance of radius. If the surface charge density was created on the surface, so what is the distance from what to the surface? Capital R, correct? So you can replace in place of small r with capital R. In place of small r with capital R. Later we will do that. First we have to differentiate that. We have to differentiate the potential. So sigma is equal to minus epsilon naught d by dr of potential. What is potential? Q by 4 pi epsilon naught 1 by r square plus a square minus 2ar cos theta whole to the power minus 1 by 2 and a small r by capital R whole square plus r square minus 2ar cos theta whole to the power minus 1 by 2, correct? So this was the V value. Now I have to differentiate this. How I can differentiate? Minus epsilon naught, take q by 4 pi epsilon naught was constant, so q by 4 pi epsilon naught d by dr. So differentiate separately. this one and this one. So first I differentiate r square plus a square minus 2ar cos theta whole to the power minus 1 by 2 minus, again I will differentiate a small r by capital R whole square plus r square minus 2ar cos theta minus 2ar cos theta whole to the power minus 1 by 2. I can cancel epsilon naught. Then I will get minus q by 4 pi. Now differentiation of this, differentiation of x to the power n, how much? N into x power n minus 1, n into r square plus a square minus 2ar cos theta n minus 1. So minus 1 by 2 minus 1, which was minus 3 by 2. Again I have to differentiate inner part, okay, inside of the bracket. So with respect to small r only, so differentiation of r square is 2r plus this was 0, a square is constant, no, 0, minus 2ar cos theta, which was 2a cos theta. So differentiation of r is 1, no, so I will have 2a cos theta. This was okay. So up to here I differentiated this one. This is one part. Again minus, I have to differentiate this term, okay. So I can write here a by r as one term, a by r whole square, and again this was small r square differentiation was 2r. Wait a minute, first I will differentiate like whole thing. What is the differentiation of x to the power n? N into x power n minus 1. So n into x to the power n minus 1. So r square minus 2ar cos theta, this power minus 3 by 2, correct. So this to the power minus 3 by 2. Again I have to differentiate inner part. What is the inner part here? This one totally we have to differentiate. So a by r whole square, r square differentiation 2r. This is capital R square, so it was 0, correct. So radius we already known, this small r was like unknown value, this radius like is a constant, so it was already known, and also we have to differentiate with respect to small r. So like it was 0 minus 2a cos theta. So here smaller there, no, so you differentiated that. So 2a cos theta finally I got that. Here see, you can observe one thing. This was sigma means like differentiation, correct. So I want sigma at small r is equal to capital R, means I want on the surface, no, I want on the surface. So for that I have to substitute in place of small r capital R. So what I will get? Minus q by 4 pi into minus 1 by 2 r square plus a square minus 2ar cos theta, correct, whole to the power minus 3 by 2 and 2r minus 2a cos theta. Up to here okay, one term, and again minus 1 by 2 a small capital R by capital R whole square plus r square minus 2ar cos theta whole to the power minus 3 by 2 and a by r whole square 2 capital R minus 2a cos theta, correct. So minus q by 4 pi. See here, like this was r square, no, like r gets cancelled, no, so a square, so a square plus r square minus 2r cos theta, a square plus r square minus 2ar cos theta whole to the power minus 3 by 2 whole to the power minus 3 by 2. So this term I can get like outside, okay, I can take it as common. So r square plus a square minus 2ar cos theta whole to the power minus 3 by 2. So finally what I will get? 2r minus 2a cos theta, no, so this 2 like if I take 2 common from this term, this denominator to numerator will get cancelled. So minus, if you multiply minus with inside, so what I will get, plus minus a cos theta will get plus a cos theta plus a cos theta, plus r will get minus r, correct. So here minus, again this see minus 1 by 2, so I took this as common outside. So inside what it was there, a square by r square into 2r minus 2a cos theta, correct. So if I can cancel this 2, like 2 common I can cancel, so r 1r get cancelled, so I will get a square by r minus a cos theta, okay. So minus q by 4 pi r square plus a square minus 2ar cos theta whole to the power minus 3 by 2. So finally what I will get, this was a cos theta minus r, this was minus, no, minus into minus how much, plus a square by r, no, a square by r minus a cos theta, okay. So plus a cos theta minus a cos theta get cancelled. So what I will get finally, minus q by 4 pi r square plus a square minus 2ar cos theta whole to the power minus 3 by 2, a square by r minus r, a square by r minus r. So minus q by 4 pi r square plus a square minus 2ar cos theta whole to the power minus 3 by 2. So a square minus r square by r, a square minus r square by r. This was the charge density at r is equal to, like small r is equal to capital R. So yeah, this was the charge density. You understood? Just using the formula we got potential there. Like this was something tricky. Like why tricky? Due to the signs. If you confuse any sign here, if you miss any sign like a negative or plus, whatever it may be, so if you miss any sign, the answer will be, you get wrong, or you can get a small confusion. So you have to be careful with the signs on while doing the calculations. So it was like calculation was something tricky, that's it. So electric field formula you have to apply there, just that's it. So sigma you will get minus epsilon dV by dr, you have to differentiate accordingly. Finally you will get this surface charge density. Yeah, thank you.